Improving Cooling System Efficiency, Part 6, Determining System Energy Efficiency. So the overall objective with regard to efficiency is to make sure that we're operating our HVAC system as efficiently as possible to remove the heat from the building. And when we say efficiently, generally we're talking about looking at the amount of energy as measured in kilowatts of power per ton of load on the system. The total energy input, as measured, electric input as measured in kilowatts, is comprised of the chiller compressor drive motor, which consumes a lot of power to drive the compressor, the condenser water pumps, the cooling tower fans, the chiller control system, and things like the transmission oil pump and motor and heater. These all consume energy. The output, as we mentioned previously, as measured by either the chilled water flow and temperature differential, the tons of output can be calculated using this simple formula to give us the tons of load or output. Or we can get that information off the control panel on the chiller as far as the load carried by the chiller as calculated by the chiller controls. And we can use these outputs then to come up with our kilowatts per tons of efficiency. The least kilowatt per ton, the better. The lower that figure, the better. One way to illustrate the cooling load, we'll touch on this briefly, just a simple illustration. If we often talk about peak tons of load, and what that refers to is what is the maximum or peak load on that cooling water system essentially at the hottest day of the year or at maximum load. Now if we were to do our calculations or take our readings off the chiller, and let's say we did that every hour and we plotted the tons load on a graph, we might get a curve that looks something like you see here, the blue line. And that's just saying that as the year progresses, you know, in many parts of the country, the hottest time of the year is in the summer, so maybe about mid-year we might hit our peak tons, and then as the weather would cool down, that would fall off. If we do that hourly, we have hours and we have tons. If we calculate the area under that curve, we have ton hours. That is another way of expressing, if we know the annual ton hours, the total heat load that's on that building. And that in essence is the amount of heat that we must remove from the building to maintain our temperature and humidity within our required set point. So the goal then is to satisfy the annual cooling load, that area under the curve, using the minimum amount of energy, minimum water, and minimum chemicals. And we can do that using some very basic strategies. One is to keep the waterside surfaces clean, as well as keeping the cooling tower clean so that we can achieve our design efficiency in terms of heat removal, not only in the chiller but at the cooling tower. We can also improve efficiency by using alternate methods such as a free cooling heat exchanger, which saves energy by taking the chiller out of service. This saves energy, but not necessarily water or chemicals, but it does have a dramatic impact on overall energy consumption. And then finally, buildings that are equipped with air-side economizers, that too helps us take much of the annual heating load off the chiller to save both, in this case, energy and water. So we need to employ these options as judiciously as possible so that we achieve our overall energy efficiency goals.